Number 19 has three parts, the first of which is looking for the x-intercepts, which we just did in a previous video, which means we're going to set the y value equal to 0. So x squared minus 4x minus 12 is 0. And then because this is a 1, we're really just looking at the 12 because 1 times 12 is 12 in order to factor this thing, to solve it. So here's 12. And we want to come up with all the ways to make a 12 product-wise. So 1 times 12, 2 times 6, and 3 times 4. Okay. Now we want the pair that actually then either add or subtract to this middle term coefficient, the negative 4. So I'm going to go with this one. I'm going to add a step that most people will gloss over when learning these for the first time. It helps with more generic forms though. So x squared, I'm going to rewrite the negative 4x as negative 6x plus 2x. Okay, so this came from the negative 4x. Now I'm going to do factor by grouping. I'm going to look at the first two terms and factor out an x, because that's what's common. And then I'm going to look at the second two terms and factor out a 2, because that's what's common. Which is nice because in this case, x minus 6 is now common, so I can pull it completely out. It may look a little funny because it's not just a single number or variable. Leaving behind x plus 2. And then, as in earlier problems, to get a product equal to 0, either one of the factors must be 0. So either this is true or this is true. Add the 6 to the other side. And separately, for this equation, subtract the 2 to the other side. So your x-intercepts are 6, 0, and negative 2, 0. Alright, now for part B, we are looking for the y-intercept. So we're going to take the same equation that they gave us, and for the y-intercept, just plug in 0 for x. So this term and this term will go away, leaving you just y is equal to negative 12. So your y-intercept is going to be 0, negative 12 as a coordinate. For part C, we are looking for the coordinate of the vertex. Let's see, there are actually three different ways to do this. In the first method, I wouldn't typically do it, but because we've already been asked for the x-intercepts in part A, the first method is using the x-intercepts. Second way to do this would be by using negative b over 2a, which I'll elaborate more when I do part 2. And then you plug that in for x into the equation to find the y value. Now, I'm not saying y times this value. I'm saying plug in negative b over 2a into the original function to find the y value. That's how this notation is. Okay. And you're going to know the difference by context. Kind of like the difference between I can kick the ball and I found the can. The difference in the words can. One's a verb, one's a noun. For part 3, you can use what's called completing the square. Okay, so for part 1, using the x-intercepts. Well, what were the x-intercepts? Let's see. Oh, 6, 0, and negative 2, 0. Alright, so some background information on this. Once you do this a couple times, it's not so bad. 1, 2, 3, 4, 5, 6, negative 2. So here's your x-intercepts. And because this is a quadratic equation, the graph of it is a parabola, which will either face up or face down. Now because the x squared term is positive, it will face up. Okay. So if you're familiar with graphing these kind of equations, that's what it's going to look like. And the vertex, or vertex, people make fun of me for saying vertex. Alright, it's going to happen in line with that negative 2, or 2 rather. So 2, comma, something. So now we're just looking for the y value. Well, if this happens halfway, that's like finding the average of two numbers. So I just need to take this negative 2 and this 6 and find the average of those. So 6 plus a negative 2 divided by 2. Well, 6 plus a negative 2 is 4. 4 divided by 2 is 2. So somewhere on this line is my vertex. So So take that 2 and plug it back into the original equation. So y equals x squared minus 4x minus 12. Y equals 2 squared minus 4 times 2 minus 12. So y equals 4 minus 8 minus 12. 4 minus 8 is negative 4. Negative 4 minus 12 is negative 16. So my vertex is 2, negative 16. Alright. Second method. I said let x be negative b over 2a. Alright. So if you're given an equation in this form, which we are, because again, here's the equation. Let me write that a little neater. No, I'm just being fussy. Let's see, x squared minus 4x minus 12. Okay, so again, this is a 1, so a is 1, b is negative 4. So x is equal to a negative, b comes with its own negative sign, 2 times 1. 2 negatives make a positive, so this is 4 over 2, which is 2. Plug that back into the equation, which we already did in part 1. So 2 squared minus 4 times 2 minus 12, 4 minus 8 minus 12, which is negative 16 again. So our vertex, 2, negative 16. Okay, so that's doing it by using negative b over 2a. Part 3, completing the square. So again, we're going to take the same equation. I'm going to leave myself a space. Now, I'm going to take this middle term, the x term, the coefficient of that x term, and I'm going to take half of that and square the result. So negative 4 divided by 2 is a negative 2, but since I'm squaring, the negative will go away, making it a positive 4. So I'm going to add 4 in the space that I left. But now I've changed the value on the right side of the equation, so I need to rebalance it by immediately removing that 4. Okay. Now, these three terms are now a perfect square by design because of what I did here. By creating that 4, I created a perfect square, which I can write in factored form as x minus 2 quantity squared. And then negative 12 minus 4 is negative 16. And now, right from this equation, I can read off my vertex. The general form for a quadratic in vertex form is this. And now I can just read off the h and k value, which is your vertex. Now, just kind of a mental device here. Whatever the sign is on the h value, change it. Okay, it's a shortcut to a way of thinking of this. And then whatever the sign is on the k value, you're going to keep it. So what I mean by that is, since it says x minus 2, instead of negative 2, I'm going to say the h value is positive 2. Since it says negative 16 for the k value, I'm just going to keep the sign and say negative 16. And so, yet again, for the third time, we get the exact same coordinate for the vertex.